interpreting this question correctly, if you get the radio transmitter centered right here and it transmits within a radius of 44 miles, that means anyone within the circle with center at, let's say, 0, 0 with radius 44 will be able to hear the radio. If you start at 049, 49 miles north of the transmitter, and start on a line that to a city that's 61 miles east of the transmitter, the equation of that line, what we really want to know is when does that line intersect the circle? And then again, if I'm interpreting the question correctly, we could call the distance where the portion of that segment is within the circle, maybe the signal distance, and the total distance we could call T sub D. And the percentage S sub D divided by T sub D converted to a percentage would give us the how much of the drive will you pick up this signal? The question is, how do you find these points of intersection? So you've got these two equations here, the equation of the circle, the equation of the straight line, which I determined by finding the slope between the two cities, negative 49/61, and then using slope-intercept form. Well, not quite. I actually used point slope. And to find the points of intersection, we're going to take this expression here, substitute it in for y, and then solve that first equation after the substitution for x, and it gets quite messy. So I'm just only going to barely get you started here, and we could go like this. This is y. I know I'm going to square the negative 49/61. So it will become, I don't need to be concerned about the negative sign. I'm going to square the x minus 61. So that'll be x squared minus 122x plus 61 squared. And that equals 44 squared. Now, solving that for x, that's a quadratic equation. We're going to have to get it in the form a squared plus b squared, ax squared plus bx plus c equals 0, and probably use the quadratic formula. And I'm not going to do that here, but I am going to share my screen and show you how I did it using the online Desmos graphing calculator. And I'll include the URL to this graph in my answer. There's the total distance, 49 square root of 49 squared plus 61 squared. After simplifying that expression, after I substituted for y in the first equation and got it in the form ax squared plus bx plus c equals 0, I found these values for a, b, and c, and I said x sub 1, quadratic formula, x sub 2, quadratic formula. Then I actually plotted the points x sub 1, f of x sub 1. And by the way, what is f of x sub 1? That's this guy right here. F of x equals negative 49/61 times the quantity x minus 61. So that allowed me to plot these 2 points right here. And then I found the distance between those 2 points to be 68.6. And if you put that distance divided by the total distance, you get 0.876. If you convert that to a percentage, it's like 88%. Okay, so I'm going to stop sharing and stop recording. And I will include the link to that Desmos graph in my answer.